Hey Bengals, it's Mrs. Hygic, and I'm going to be talking to you today about the lunar cycle. The objective for this video, as seen on your matrix, is to demonstrate and predict the sequences of events in the lunar cycle. And you have two essential questions that you need to make sure you answer on your Wix. Number one, why does the appearance of the moon change? And number two, about how long does each moon phase last? You also have an action item, which is to predict moon phases using a calendar. And there will be, towards the end of the video, will be our moon phase predictions. But I also want you to draw a picture showing the complete lunar cycle, and I will tell you at what time I want you to take the illustration on the screen and draw it on the back of your Wix. So let's get started with the lunar cycle. First, let's discuss some moon basics. The moon will revolve around the Earth one time every 28 days. So here's the Earth, and the moon revolves or orbits around the Earth. And this orbit takes about a month or 28 days to complete. So this revolution of the moon around the Earth takes about 4 weeks. As the moon is revolving around the Earth, it's also rotating on its axis, spinning on its axis, just like the Earth spins on its axis. But the Earth spins once every 24 hours, giving us 12 hours of day, approximately, and 12 hours of night, depending upon where you are on the Earth. If the moon, on the other hand, rotates much slower. It takes 28 days for the moon to make one complete spin or rotation around its axis. So as it's revolving around the Earth, it's also rotating on its axis, and it takes approximately 28 days for a revolution and also 28 days for a rotation. The moon does not produce its own light, but the light that we see from the moon is actually just reflected light from the sun. The moon's surface is very much like a mirror. It reflects sunlight. So when we see light from the moon, it's not light that the moon is producing, but light that the moon is reflecting. Now, we will see different amounts of reflected light when the moon is in the different positions as it is revolving around the Earth. And this apparent change in shape of the moon is called a moon phase. So, essential question number one, why does the appearance of the moon change? The moon appears to change because we see a different amount of reflected light when the moon is in a different position in its revolution around the Earth. And these shapes are called moon phases. It takes approximately 29 days for the moon to revolve around the Earth and go through all of its moon phases. And there are approximately 3.5 days between each phase. So that's essential question number two. About how long does each moon phase last? Well, each moon phase lasts about 3.5 days. So if we begin an orbit or a revolution, it takes 3.5 days to get from one phase to the next, to the next, to the next, to the next. 3.5 days to get to the next, and the next, and the next, and the next. So if you add all that up, you get about 28 days. It's 1 week to get through a quarter of the revolution of the moon around the Earth. So 1 week, 2 weeks, 3 weeks, 4 weeks total to make one full revolution. Now when you look, let me get rid of that hyperlink. Sorry guys, I forgot to do that. Okay, when you look at the moon, different sides of the moon will be lit up or illuminated. When the right side of the moon is illuminated, the moon is gaining light because it's in the beginning part of its moon phase, and we call this a waxing moon. You can kind of take this moon and make a B standing for the beginning, or the moon is being born, another word that you might have heard before, during a waxing phase. So when the right-hand side of the moon is lit up, we call this a waxing phase. Now, once the moon has gained as much light as it can, then the light will begin to lose or decrease. And so when the left side of the moon is illuminated, you can make a D here with the left side being illuminated, this is when the moon is losing light, it's descending. My son learned it as dying when he was in elementary, so it's being born when the light's on the right, it's dying when the light is on the left, and when the left-hand side is illuminated, we call this a waning phase because the moon is losing light. So let's take a look at once again, remove the hyperlink. Let's take a look at the moon phases. Notice that the sun is on the right-hand side of our Earth and moon. Here we are on the Earth. Here's the moon in its 8 different positions as it revolves around the Earth. Notice that half of the moon is always illuminated, but we don't always see the half that's being illuminated. So in this position here on the Earth, when we look at the moon, all that we see is in shadow. We call that the new moon. And then it moves into this position, and on the Earth we look at it and we see that most of the moon is in shadow with just a sliver of light over here on the right hand side. So what we would see in the sky is the moon looking like this. The right hand is illuminated, it's in a crescent shape, so we call this a waxing crescent. The moon then moves into this position. From the Earth we look, we can see that half of the moon is illuminated. It's the right half of the moon. We don't call it a half moon though. Since the moon is 1/4 of the way around its orbit, we call this the first quarter moon. So it continues to move, and now when we look at the half that we can see, most of it's lit up, the right hand. Just a sliver over here is still in shadow. So when we look at the sky, we would see this phase here. The right side is lit up, so it's a waxing phase, and since it's a bulge of light, we call this a gibbous. Then the moon moves into this position here, where here we are on Earth, and we look up at the sky, and we can see the full half of the moon that is facing us is illuminated now. So we look at the moon and we see all of it being lit up like this, and we call that a full moon. And we are 1/2 of the way around the cycle now. We're about 14 days into our cycle. So we continue the orbit. The moon moves into this position. So here we are on Earth looking again. We see this half being lit up. If you're looking, you kind of have to turn your head a little bit, but you see that the left side is now primarily lit up with just a little bit of light, shadow over here on the right. So what we're looking at now is a waning gibbous. The left side is illuminated, so it's waning, and it's a bulge of light, and so it's a gibbous. The moon then moves into this position here. We're on Earth, we're looking this way, we see this half being illuminated, or this half of the moon is what we see. Half of it's lit up, and it's the left half, and since we're 3/4 of the way around, we're in the 3rd quarter, also sometimes known as the last quarter moon, when the left half is lit up. Then we move into this position here, again from the Earth. This is the half of the moon that we can see. Most of it's now in shadow with just a sliver on the left being lit up. So we look at that. It's the left side that's lit up, so that's waning. The light's in a crescent shape, so this is a waning crescent. And then the moon moves back into the position that it started in, where the half of the moon that we can see is in shadow. So we call this a new moon. And we are 28 days or 4 weeks now that it took for the moon to move through all of these different positions, showing us all of the different 8 moon phases that we would see from Earth. Now, if we rotate the sun and put the sun on the other side here, the order of the phases don't change, but the position of the phases do change. No matter where the sun and the Earth is, the position of the moon between the sun and between the Earth, that's going to be the new moon position, or the starting position. And then we simply rotate counterclockwise through all 8 of the different moon phases. So we would be waxing at the bottom to the full moon, and then waning on the top back to the new moon. Now this is the picture that I want you to draw on the back of your wick. So if you could pause the video, draw this picture, make sure you identify which side of the picture the sunlight is coming from. Make sure you label the 8 phases and you draw what these 8 phases would look like from Earth. And when you're done, you can push play again. So go ahead and push pause and draw your picture. Now that you've drawn your pictures, let's take a look at this simulation of the moon phases. So we have the sunlight over here on the left-hand side. Here's the moon, here's the Earth, and here's us on the Earth. Now in our simulation, we are going to see the Earth rotating, and it's going to rotate 28 times as the moon makes its orbit, because again, it takes 28 days for the moon to make its full revolution. So in this position here, with the sun behind the moon and the moon's between the sun and the Earth, if we were to look up at the sky, this is what we would see. So we would see a new moon. So as the moon moves out of that position and into the next position, notice the light is growing. It's growing from the right. So this is a waxing moon phase. We're now in the waxing crescent. The moon continues. It's almost 1/4 of the way through its orbit. Still, the right-hand side of the moon is illuminated, so that was the first quarter that we saw. Moving now into the gibbous location, or the gibbous position. The right-hand side is lit up, so that's a waxing gibbous. Moving now into our halfway mark. Halfway, we see all of the moon being illuminated. This is a full moon now. Now the moon is going to begin to die or lose light. So this is now the lit side is the left side. So this is a waning moon or a waning gibbous. And then it moves into the 3/4 of the way around, or the third quarter or last quarter moon. And then we, again, the light is still on the left side, so it's waning, and now it's a waning crescent. And then 28 days here since the beginning, the moon moves back into its new moon position. And you can rewind and play that through as many times as you would like. So this is the lights now on the right-hand side, and we're just going to take a look at this. This is our view from the Earth. So in this position, what is the moon phase? What would we see? Well, it would be completely in shadow. So the view from the Earth that we can see right here, we're not going to see anything because it's a new moon. Moving into this position, what would we see? We would see this moon. And what is this moon phase called? The right-hand side is illuminated, and it's shaped like a crescent, so this is a waxing crescent. Into the first quarter, okay, we would see this moon phase, and that's the first quarter moon. The half of the moon is illuminated. It's the right half of the moon, so it's a first quarter. Into this position here, we would see this moon phase. The right side is illuminated, so it's waxing, and it's kind of a bulging of light, so that's a waxing gibbous. Then we get into this position here. This is a position that gets kind of confusing, especially when you're looking at this in 2 dimensions, because a lot of people think that you're going to get an eclipse here, a lunar eclipse, but that's not true, because the Earth, the moon's orbit is at a slight angle. So in this position here, we will actually see the moon. We'll see all of the moon, and so this is a full moon phase. And then we get into the phase of the moon where the moon begins to shrink. Here, the left-hand side is now illuminated, so this is a waning gibbous. And then here, the left side, half of the left side is illuminated, so we have a last quarter or third quarter moon. And then in this position here, the left side is illuminated, so this is waning, and it's a crescent shape, so we have a waning crescent. Back to our new moon position. In just a moment, we'll be talking about moon prediction. So now that we have studied the different moon phases according to the position the moon is in its revolutional path around the Earth, let's talk about how we can predict moon phases. So a couple questions, and these are the questions that I would like you to answer on your Wix as your action item, predicting the moon phases using a calendar. So in addition to the picture of the moon phases, I also would like you on the back of your Wix to answer these questions. So how many days does a moon phase last? Well, according to our notes, a moon phase lasts approximately 3.5 days. So you can look up here and you can see that we have about 3.5 days. Here's a waxing gibbous, lasts about 3.5 days, and then we have our full moon, which is about 3.5 days, and then we have our waning gibbous, which is about 3.5 days, and then we go to our last quarter, and then we have our waning crescent, which lasts about 3.5 days, and then our new moon. And so each moon phase on a calendar lasts about 3.5 days. So looking at this calendar, we don't have all of the days moon phases inserted, but we can use the moon phases that we do know to make a prediction of what a moon phase should be on a certain calendar day. So what is the moon phase on December 2nd? Well, we look at December 2nd and we see that this is a first quarter moon. Our light's on the right hand side, so it is at the beginning of the moon phase and it's half lit, and so this is our first quarter moon. We can use that first quarter moon on the 2nd to then predict what the moon phase would be on December 5th. December 5th is approximately 3 days later. 1, 2, 3. Approximately 3 days after a first quarter moon, we move into the next moon phase, which is a waxing gibbous. So we just predicted the moon phase on December the 5th using a moon phase from December the 2nd. You just have to remember your 3.5 day time frame. What is the moon phase on December the 18th? Well, here's December the 18th. We now are looking at the left side of the moon being illuminated, and so this is when the moon is shrinking or dying. So this is a last quarter or third quarter moon. Using that, we can then predict what the moon phase would be, what the moon would look like, what the moon phase would be on Christmas, December the 25th, which is 1 week later. And so if you kind of picture your moon phase, 3.5 days later, boom, 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 somewhere around here, we'd probably start seeing a waning crescent, and then boom, 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 here we should see a new moon. So Christmas time, a week after the 18th, we can predict that we would see a new moon in the sky. Or we really wouldn't see a moon because it's all in shadow, new moon phase. And so that's how you make moon phase predictions. You simply find a date where you know the moon phase, and then you count forward or you count back, and you move forward or you move backward in your moon phase diagram to help you identify what the moon phase would be on a certain day. Thank you, Bengals.